Welcome back to the Nocturnal Astronomer. This is a place for quiet minds, for those hours when the world has slowed down and your thoughts turn upward. Whether you are winding down for sleep or simply looking for a little relief from the day, you are exactly where you should be. I'm your host, Atlas Reed, and I'll be your guide through the cosmos this evening. Tonight, we are venturing somewhere unusual. Not to the calm, familiar planets of our own solar system, but to worlds discovered circling distant stars. Worlds so strange that when astronomers first described them, they sounded more like something dreamed up for a novel than something confirmed through careful, patient observation. We will visit a handful of these worlds tonight. A planet where the sky rains glass sideways. A planet darker than the deepest coal. A planet that may be built in part from diamond. A planet where iron itself falls as rain. Each one a gentle reminder that reality outpaces imagination. Let's dive in. Part 1. The world where the sky rains glass sideways. About 63 light-years away, in the small constellation of Vulpecula, orbits a planet called HD 189733b. From a distance, it looks peaceful, a deep cobalt blue world early observers compared to our own. That comparison does not hold up. This is a hot giant, a massive world of gas circling its star far closer than Mercury circles our sun. One side of the planet always faces that star, locked in permanent daylight, while the other rests in permanent night. The dayside temperature climbs past 1,000 degrees Celsius. At that heat, silicate, the mineral family that makes up much of our own planet's crust, does not stay solid. It turns to vapor. Powerful currents of superheated air carry that vapor from the blazing day side toward the cooler night side, where it can finally change form again. As the vapor cools, it condenses, not into water droplets, but tiny hardened particles, largely two common silicate minerals called enstatite and fosterite. In plain terms, this is molten rock cooled into something close to glass, falling through this world's thick, hazy atmosphere. Here is where the story becomes hard to picture calmly. Currents in this world's atmosphere move beyond 8,000 kilometers per hour, several times faster than sound travels here on Earth. Falling glass caught in that flow is driven sideways, so rain on this planet moves across the sky. It is worth sitting with that image, not with alarm, but with quiet astonishment. A world where rain does not obey the simple downward pull we take for granted, where an entire weather system moves sideways because the forces at play are far larger than anything familiar to us. Before telescopes like Spitzer and Hubble studied this world closely, nobody had proposed anything quite like it in serious fiction. Writers had imagined oceans of fire or skies filled with ash, but a steady sideways rain of glass was not a scenario anyone had thought to write down. Yet here it is, documented through years of spectroscopy, confirmed by independent teams studying starlight as it filters through this world's atmosphere during its transit. The findings were not one lucky observation. They were built from repeated measurements, the slow, careful way real discoveries tend to happen. The universe needed no embellishment to become strange. Astronomers simply pointed careful instruments at a distant point of light, gathered data over months and years, and the truth that emerged was stranger than anything they had gone looking for. So, somewhere out there tonight, 63 light years away, glass falls sideways through a hazy blue sky, indifferent to us entirely. There is a kind of peace in that indifference, in knowing the universe carries on its strange, patient business, far beyond our small earthly concerns. Part 2. The steam world hidden inside a water planet. About 40 light years away, in the constellation Ophiuchus, orbits a smaller world, roughly 2 3/4 times the width of Earth. Discovered in 2009, it caught attention for one unusual property: its surprisingly low density. That density, just under 2 grams per cubic centimeter, ruled out a purely rocky world, which would be far denser, yet was too high to match an ordinary gas giant, far lighter still. Astronomers proposed a genuinely new category of planet, one built largely from water. Early observations suggested this planet's thick, warm atmosphere might be dominated by water vapor. Later Hubble studies confirmed a steamy, humid outer layer, unlike anything found among planets in our own solar system. Researchers began calling it, simply and memorably, a water world. Beneath that steamy atmosphere, conditions grow strange fast. Given the planet's heat and pressure, any water deep inside likely exists not as familiar liquid or gas, but as a supercritical fluid, a state where the usual line between liquid and gas disappears entirely, replaced by something else. More recent James Webb observations deepened this picture, detecting clear signs of a metal-rich, water-heavy atmosphere. Researchers now suggest this world may have formed farther out in a colder region rich with ice, before gradually drifting inward to its present warmer position. There is comfort in imagining a planet built so thoroughly around water, even if that water bears little resemblance to anything in an ocean or rain shower on Earth. It is the same simple molecule, hydrogen and oxygen, arranged into something almost unrecognizable under pressure. Supercritical fluid is hard to picture because it behaves unlike anything in daily life. It can flow through solid material the way a gas would, yet hold a liquid's density. Imagine steam thick enough to feel weighty, filling the deep interior of an entire planet, quietly. This world also matters scientifically, an entirely new category that did not fit neatly beside rocky planets or gas giants astronomers had studied for so long. Its discovery helped open a whole field, the study of what researchers now call sub-Neptune worlds, planets between Earth and Neptune. It is a gentle reminder that something as simple and familiar as water can produce entirely unfamiliar outcomes, given enough scale, heat, and time. The same substance filling a glass beside your bed may, elsewhere in the galaxy, exist as a vast, dense interior beneath endless humid cloud. So, somewhere tonight, 40 light years away, a small world quietly holds its steamy secret, its water existing in a state with no true equivalent on Earth. There is something soothing in imagining that gentle molecule, the same one filling our oceans, taking on such strange, patient new forms. Part 3, where iron falls from the sky like rain. 640 light-years away, in the constellation Pisces, orbits a giant world called WASP 76b. Discovered in 2013, it circles so close to its star that a full year lasts less than 2 days. One side faces permanent daylight, the other permanent night. In 2020, astronomer David Ehrenreich and his team, using an instrument named Espresso on a large telescope in Chile, reported something remarkable. On the scorching day side, past 2,400 degrees Celsius, even metal does not stay solid. Iron itself turns to vapor. Currents moving faster than 11,000 miles an hour carry that vaporized iron toward the border where night begins. There, temperature drops sharply down to around 1,500 degrees Celsius, cool enough that the iron vapor can no longer remain a gas. It begins to fall. The result, the team reported, is a genuine rain of molten iron near the line where day meets night. Ehrenreich put it simply, saying this planet gets rainy in the evening, except it rains iron instead of water. One of the most striking weather reports for any distant world. Later observations added nuance, as good science often does. A 2021 reanalysis suggested some of the earlier signal could reflect temperature differences across the planet rather than condensation alone. Astronomers have not fully resolved the question, and they say so plainly in their published work. That open uncertainty is worth pausing on, because it says something true about how discovery works. Scientists did not simply announce iron rain and move on. They published their reasoning, invited challenge, and adjusted their confidence as new evidence arrived. Wonder here includes the honesty of not yet knowing. Even with that uncertainty, the underlying facts remain extraordinary. This is a world hot enough on one side to vaporize metal and cool enough on the other to let that same metal fall from the sky. No planet in our solar system does anything close to this. Consider the temperature gradient involved, roughly 900 degrees Celsius between one side of a planet and the other. That difference drives currents powerful enough to carry an ocean's worth of vaporized metal across a hemisphere before it falls back down as liquid rain along the cooler edge. Researchers have also detected hints of a glory, a rainbow-like halo of light in this atmosphere, the first time such an effect has been spotted beyond our own solar system. Even in a place this extreme, there is beauty, colour scattered gently through skies that seem entirely hostile. So, somewhere tonight, 640 light-years away, a border of endless twilight divides a world in two, and along that seam, iron condenses and falls, quietly, forever. There is something almost soothing in a process this vast, simply continuing, undisturbed, indifferent to how strange it seems. Part 4. A world with clouds made of rubies and sapphires. Just over 1,000 light-years away sits a giant planet named Hat P7b, discovered in 2008 and studied for 4 years using the Kepler Space Telescope. In 2016, astronomer David Armstrong announced something that sounds, at first, like it belongs in a fairy tale. His team had been watching how reflected light from this planet's atmosphere changed over time. The brightest point on the planet kept shifting position rather than staying fixed toward the star. A shift caused by moving clouds carried by a powerful current circling the equator. What made this remarkable was not just the moving clouds, but what researchers believe they are made of: corundum, a crystalline form of aluminum oxide. Corundum is the very mineral that forms rubies and sapphires here on Earth, depending on which trace elements happen to color it. On the day side, temperatures soar past 2,500 degrees Celsius, hot enough to vaporize aluminum straight into gas. Currents carry that vapor toward the cooler night side, where temperature finally drops low enough for the corundum to condense back into solid, crystalline form. If the models hold true, this means clouds, perhaps even gentle precipitation, made of the same crystals we treasure as gemstones, drifting through a world we will likely never visit. It is the first documented weather system ever observed on a giant planet beyond our solar system. We have spent thousands of years mining, cutting, and treasuring rubies and sapphires, building cultural meaning around small crystals. And here, an entire planet may be built around that same chemistry, on a scale we can barely picture. Nobody suggests these are gemstones in the sense a jeweler would recognize, cut and polished for display. These would be raw crystalline particles formed under punishing heat, then swept through a fierce journey between day and night, before falling as something closer to fine, glittering grit. Still, the poetry is difficult to resist. A planet where the very substance of rubies and sapphires exists not as rare treasure, but as ordinary weather, as unremarkable from that world's view as rain is to us. Scarcity, it turns out, is often just a matter of distance. This discovery also mattered scientifically, well beyond its beauty. It was the first time researchers documented an actual changing weather pattern, not simply a fixed feature on a gas giant outside our solar system. The clouds moved, the brightness shifted, a living system caught in the act. So, somewhere tonight, more than 1,000 light years away, currents carry crystal-laden clouds slowly around a scorched, distant world, unseen by anyone, needing no audience at all. There is calm in imagining beauty that exists simply because physics allows it, apart from whether anyone notices. Part 5. The planet that may be built from diamond. About 41 light-years away circles a planet called 55 Cancri E, roughly twice the width of Earth and nearly 9 times its mass, a category astronomers call a super-Earth. It circles so closely to its star that a full year there lasts under 18 hours. In 2012, researchers proposed something striking about this world's makeup. Its host star holds an unusually high ratio of carbon to oxygen. If the planet formed from similar material, its interior might not resemble Earth's oxygen-rich rock, but instead be built largely from carbon. Under pressures reaching millions of times what we feel at sea level, carbon does not stay as soft graphite. It can crystallize into the same rigid structure found in diamonds. Some researchers calculated that as much as a third of this planet's mass could exist in that crystalline form. This is why the world quickly earned its nickname, the Diamond Planet, appearing in headlines worldwide. It is a beautiful image, a planet built partly from the same crystal we treasure in wedding rings, sitting in orbit around a star visible with careful eyes on a clear night. More recent observations from the James Webb Space Telescope have complicated that picture. Researchers now believe the surface likely holds a vast, glowing ocean of molten rock, a lava world rather than a solid diamond one, with a thin, shifting atmosphere shaped by that bubbling magma below. This shift in understanding is not a failure of earlier science, but exactly how good science should work. The diamond hypothesis was never presented as certain fact, only as one explanation consistent with the evidence available. As instruments improved, the picture sharpened, and researchers followed where it led. It is entirely possible that both descriptions hold some truth. A surface of molten lava does not rule out a carbon-rich, partly crystalline interior deep beneath that glowing ocean. The planet may quite literally hold a heart of diamond, wrapped in a restless, burning outer layer. Either way, the wonder remains fully intact. This is a world where familiar materials, rock and lava we know from our own planet's youth, exist under pressures and temperatures far beyond anything found on Earth. Familiar chemistry, entirely unfamiliar conditions, producing something genuinely hard to picture calmly. Scientists have found signs this planet continually regrows its thin atmosphere, likely replenished by ongoing volcanic activity from that molten surface. Even after losing an earlier atmosphere to its punishing star, the planet seems to generate another, a patient cycle of loss and renewal, largely unwitnessed. Out there tonight, a small, brilliant world circles its star every 18 hours, its surface glowing with molten rock, its interior perhaps holding crystal formed under pressure we can barely imagine. Whether diamond or lava proves more accurate, it remains a world built from extremity. Part 6. The world that used to be a star. Roughly 4,000 light-years away, in the constellation Serpens, spins a rapidly rotating neutron star, a millisecond pulsar completing more than 10,000 turns every minute. In 2011, astronomer Matthew Bales and his team found this tiny 20-kilometer star has a small, dense companion nearby. That companion completes a full orbit in just over 2 hours, closer than our own sun's radius. Careful calculations of its size and mass revealed something astonishing: a density of 23 grams per cubic centimeter, twice that of lead, No ordinary gas giant could ever be that dense. Researchers proposed instead that this small world is not a planet in the usual sense, but the stripped-down remnant of an entire star, once perhaps an ordinary companion, similar in size to our own sun long ago. Over great stretches of time, the more massive companion, the one that became the pulsar, gradually siphoned away that star's outer layers, its hydrogen and helium, piece by piece. What remained was a small, dense core, likely carbon and oxygen, compressed under conditions no laboratory could replicate. Under that pressure, the remaining carbon is thought to crystallize, much like the process believed to occur inside 55 Cancri E, taken to an even more extreme degree. The result may be, quite literally, a planet-sized diamond orbiting the tiny remains of its former companion. Sit with that idea a moment, because it reshapes tonight's entire premise. This is not simply a planet that happens to contain diamond material. This may be a planet that used to be an entirely different kind of body, a full-sized star, slowly reduced into something unrecognizable. It raises a genuinely strange question about categories themselves. What do we call a body that began its life fusing hydrogen like any ordinary star, only to be stripped down over vast spans of time until it settled into something small enough to be called, reasonably, a planet? Researchers have even offered an alternate explanation, that this dense companion could be made of something even stranger, an exotic form of matter theorized only under the most punishing pressures. Either way, calling this simply a planet barely captures how strange its history truly is. There is something quietly moving about transformation on this scale. A star worn down slowly by gravity and time, becoming something else entirely. A small, dense, crystalline body, still circling its former companion, bound by the same gravity that once connected them as equals long ago. So, somewhere tonight, 4,000 light years away, a diamond world, or something close to one, spins tightly around the collapsed heart of a dead star, completing an orbit before you could finish a short conversation. There is a strange peace in something so extreme settling into its rhythm. Part 7. The planet slowly being swallowed by its sun. About 1,200 light-years away, in the constellation Auriga, orbits a giant world named WASP-12b. It circles its star in just over 1 day, sitting so close that the star's gravity has physically reshaped it, stretching its usual round form into something like an egg. In 2010, Using the Hubble Space Telescope, researchers observed the planet actively losing material to its star. Gravity gradually pulls gas from the world's outer atmosphere, drawing it into a thin disk that slowly funnels toward the star, a rare and clearly documented process. Scientists calculate this planet loses roughly 6 billion tons of mass every second. That figure is difficult to hold in mind, so consider this instead. Even losing mass that quickly, researchers suggest the planet still has around 10 million years left before its star fully claims it. Later studies, tracking this planet's transits across many years, found its orbit is measurably shrinking. The gap between planet and star narrows steadily, confirming this slow process is not new, but has been unfolding for a very long stretch of time already. Spitzer observations added one more detail. This world's atmosphere holds more carbon than oxygen, an unusual imbalance, hinting its interior may differ from the oxygen-rich rock making up planets like our own, possibly holding carbon-rich minerals similar to others we have visited tonight. There is a certain gentleness available in how we hold this story, even though the physics describes a genuine ending. Every star and planet exists within a slow unfolding of time, some processes lasting billions of years, others, like this one, playing out over 10 million. From a human view, 10 million years is unimaginable, yet on a cosmic clock, it is closer to a single held breath. This planet is not being torn apart suddenly, but drawn inward gradually, across a timeline that dwarfs the entire span of human history many times over. It is worth remembering our own sun will, in roughly 5 billion years, expand into a red giant and reshape the inner solar system as we know it. Every star eventually changes its relationship with nearby worlds. This distant planet simply shows that story already well underway. Nothing in the cosmos exists forever unchanged. Yet these transformations unfold across timescales so vast they rarely need to trouble us personally. We are permitted to observe these slow endings with curiosity rather than worry, like watching a distant tide. Up there tonight, 1,200 light years away, a stretched, egg-shaped world drifts slowly inward, losing a little more of itself with every orbit. It is not an ending happening today, but a patient unfolding. One small piece of the universe's long, unhurried habit of change. Part 8. The planet darker than the deepest coal. About 750 light-years away, in the constellation Draco, orbits a Jupiter-sized world named Tress 2b. In 2011, astronomer David Kipping set out to measure something surprisingly difficult: exactly how much starlight this planet reflects back into space. Most giant planets, including our own Jupiter, reflect a fair portion of light. Jupiter's pale ammonia clouds bounce back more than a third of the sunlight striking it. Kipping expected Tres 2b, a similar kind of giant world, to behave in a broadly comparable way. What he found instead was startling. Tres 2b reflects less than 1% of the light falling upon it, absorbing nearly everything and giving almost nothing back. Coal, one of the darkest ordinary materials on Earth, still reflects around 5% of the light striking it. This distant world is measurably darker than coal, darker even than the blackest acrylic paint used to test light absorption. If you could hold this planet safely in your hand, it would appear as a nearly featureless black sphere, with perhaps a faint reddish glow from its own heat. Nobody is entirely certain why. The planet sits so close to its star that reflective clouds, the kind that make gas giants bright, cannot form. Its thick atmosphere may instead hold absorbing vapors, sodium, potassium, or titanium oxide, though even these fail to fully explain such darkness. There is something almost meditative about a planet defined not by what it shows us, but by what it refuses to reflect. Every other giant world we know has some signature, some color, some pattern of cloud. This one simply swallows the light and keeps it patiently in orbit. Kipping suggested a fitting nickname, Erebus, after the ancient Greek personification of primordial darkness. It is a fitting image, though the planet is far from cold. Its closeness to its star heats it to nearly 1,000 degrees Celsius, a hot, glowing darkness rather than a frozen one. Before this discovery, models predicted hot giant planets could be, at most, about as dark as Mercury, which reflects roughly 10% of the light hitting it. Tres 2b broke that expectation entirely, reflecting 100 times less light than those older models allowed. This is often how discovery works, quietly overturning careful predictions rather than announcing itself with fanfare. Nobody set out looking for the darkest planet ever measured. They set out to understand ordinary reflected light and found something that redefined darkness on a planetary scale. Right now, somewhere in Draco, a giant world turns in near total blackness, reflecting almost nothing back toward its neighboring stars. There is a strange comfort in imagining it, a planet happy to keep its own secrets, existing quietly without needing to be seen by anyone at all. Part 9. A world with 2 sunrises every single day. roughly 245 light-years away, sits a system with an unusual layout. 2 stars orbiting one another closely, and a single planet, Kepler 16b, circling both together. Discovered in 2011, it remains the first confirmed example of this kind of arrangement. The 2 stars are quite different. One about 70% the mass of our Sun, the other only about 20%. They circle each other every 41 days, while the planet, a cold, gaseous world roughly Saturn size, orbits the pair every 229 days. Detecting this planet required real patience, because both stars periodically pass in front of each other, dimming their combined light in intricate patterns. Isolating the fainter dimming caused by an orbiting planet took careful, sustained observation across many transits before the discovery could be confirmed. If you could somehow stand on this world's surface, though its gaseous nature would make that difficult, you would see 2 suns sharing the same sky, shifting as their own orbit carried them across one another. The planet itself stays quite cold, well below freezing. Since this discovery, researchers using a technique called the transit method have found more than a dozen additional planets orbiting pairs of stars, confirming that this arrangement, once considered too unusual to expect, is common throughout our galaxy, scattered quietly among countless other systems. A planet built around companionship rather than solitude, orbiting not one steady light, but 2, bound together in their own patient, circling relationship. Our own Sun stands alone in the sky above us. This world never experiences that particular kind of quiet. Before this planet's confirmation, a world with 2 suns existed mostly as a compelling piece of imagined storytelling, a way to signal an unfamiliar, far-away setting. Its confirmation shifted that image from imagination into documented fact, found through years of careful measurement rather than invented for effect. Researchers had long suspected planets could form and endure within binary star systems, but many worried the shifting gravity of 2 stars might make stable orbits nearly impossible over long stretches of time. This world's steady, confirmed orbit showed such planets can indeed persist for millions of years. It is worth pausing on how ordinary this arrangement may be once you step back far enough. Most stars in our galaxy exist not alone, but in pairs or small groups. A planet with 2 sunrises may prove less an oddity than simply another common shape a system can take. Out there tonight, 245 light-years away, a cold, quiet world circles 2 companion stars, watching their light shift and blend above it. There is a gentle beauty in that image, a planet held steady not by one star's pull, but by the shared gravity of two. Part 10. The first worlds ever found beyond our Sun. In 1992, astronomers Alexander Wolszczyn and Dale Frail made an announcement that quietly reshaped our understanding of the universe. Using the Arecibo radio telescope, they detected the first confirmed planets orbiting a star other than our own, years before any such planet was found circling an ordinary star. What made this unusual was the star itself, a millisecond pulsar, roughly 2,300 light-years away. Pulsars are tightly compressed cores left behind after a massive star explodes, and this one spins over 160 times a second. Wolszczyn and Frail did not see these planets directly. Instead, they noticed something subtle, tiny, regular shifts in the precise timing of the pulsar's radio pulses, caused by the gentle gravitational tug of unseen bodies orbiting it. From that faint pattern, they calculated 2 and later 3 small worlds. The 2 larger planets each carry roughly 3 to 4 times the mass of Earth, while the smallest is barely twice the mass of our Moon, the least massive planet ever confirmed beyond our solar system. All 3 orbit within weeks, circling a star that had already ended its life. This raised a genuinely strange question astronomers still explore today. How can planets exist around a star that exploded so forcefully it should have scattered any nearby worlds entirely? The leading explanation holds that these planets are second generation, formed later from the leftover disk the explosion left behind. The very first worlds ever confirmed beyond our own solar system were not gentle Earth-like planets circling a friendly star, but small rocky bodies orbiting the compressed, radiation-soaked remains of a star that had already ended. Before this discovery, many astronomers assumed the first confirmed planet beyond our Sun would likely orbit an ordinary, Sun-like star, resembling our own solar system in miniature. Instead, the honor went to a system that seemed almost designed to be hostile to planets. And yet, there they were. The discovery briefly faced real skepticism within the scientific community, precisely because the setting seemed so unlikely. It took further, careful confirmation, researchers detecting the subtle pull the 2 larger planets exert on one another, before the wider community fully accepted what Wolszczyn and Frail had found. This moment mattered far beyond 3 small worlds. It proved planets are not rare, fragile exceptions tied only to peaceful, stable stars like our own. They can form and persist in some of the most extreme places the universe offers, a lesson that quietly shaped planet hunting for decades after. So, 2,300 light years away, 3 small worlds continue their quiet orbits around the spinning remains of a star that ended long ago. They were the first confirmed proof that our Sun's family of planets is not unique. That proof has stood for decades. And on that note, we come to the end of tonight's journey through worlds that, by early expectations, should not exist. Skies that rain glass and iron, a planet darker than coal, a possible heart of diamond, clouds built from rubies, worlds circling dead stars. Reality needs no embellishment. What strikes me most is not the strangeness itself, but what it quietly implies. Every one of these worlds was once entirely unknown to us, revealed only by a careful telescope or a subtle shift in starlight. And still, for all that vastness, none of it demands anything from you. These worlds do not weigh our decisions, or judge our mistakes, or care whether tomorrow goes well. There is something relieving in that. The pressures that feel enormous, a hard conversation, an uncertain future, a restless mind at midnight, exist within one small corner of a nearly endless expanse. Consider for a moment the sheer scale involved tonight. Worlds 40, 60, 600, even 4,000 light years distant. Each of those numbers is light that left its source long before you were born, sometimes before recorded history began, only now reaching this small, quiet room where you rest. That kind of distance has a gentle way of resizing our worries without dismissing them. Your concerns remain real and valid, but they exist inside a universe so enormous that even planets built from diamond or skies that rain molten iron are ordinary details among billions of similarly strange worlds. I find real comfort in that scale, and I hope in some small way you do too. Not because we are unimportant, but because there is relief in remembering how much room the universe holds. Enough room for glass rain and ruby clouds, and enough room for you. So, if your mind is still racing tonight, try picturing one of these worlds. The steady, sideways fall of glass through a hazy blue sky. The patient orbit of 2 small planets around the collapsed heart of a long-dead star. Let that image sit quietly behind your eyes. None of this is meant to make you feel small in any diminishing way. It is meant gently as an invitation. You are a small, warm, thinking part of an unimaginably large and patient universe. One that has quietly built strange, beautiful things for billions of years. Tonight, you noticed. Thank you for spending this quiet hour with me, drifting through skies made of glass and iron and crystal, past stars slowly becoming something else. I hope some of that vastness has settled gently over you, easing the weight of today and making room for real, restful sleep to arrive. This has been the Nocturnal Astronomer. I am Atlas Reed, wishing you a calm mind, a quiet room, and a sky full of worlds you may never see, yet imagine.